Hello. What we are doing today is moving on, continuing with the idea of converting between moles and grams and also into individual atomic particles. So, what we've been doing over the last few days is converting between mass and moles using the atomic mass of each element. So what you were doing is coming over here to your handy dandy periodic table and identifying the different elements uh, and looking at what the mass of that particular element was. Today we're going to take that just a step further, and you're going to be looking at the molar mass for individual compounds instead of the atoms themselves. So for example, on the sheet that I've given you, you have copper 2 chloride. So I'm looking down here at the second paragraph. So the formula for copper 2 chloride is CuCl2. In physical science, you were talking about this with Mrs. Engel, discussing what the different formulas were for these particular compounds. And so what we're going to do today is put together the masses of each individual atom in order to make up the total mass of the compound. So we have one copper and we have two chlorines. So I'm going to address copper first. If I come back here to my periodic table, here's copper, which has a mass of 63.546. Okay, so what I did is went back to my table here, and there's 63.546, so that is the atomic mass unit. Uh, but then I also need the chlorine that is involved there as well. So if I go back here, chlorine is over here, it's a halogen, and it has a mass of 35.45. So I'm going to add that to my 63.546. However, there's two of them. So I'm going to add it twice. So down here I have 63.546 representing the single copper ion. I have 35.45 plus another 35.45 for the two chlorine atoms. So the total molar mass for this compound is 134.36 AMU. And so AMU stands for atomic mass unit, but we've been just looking at it as 1 mole equals 134.36 grams. We're using that as our conversion factor. So in order for us to use this later on, then we need to be able to identify those particular compounds and figure out what the masses of those compounds actually are. Okay, so looking below here, coming to our first set of problems, our first compound is sodium hydroxide. Okay, this is an ionic compound, so we have a single sodium ion. We have oxygen and hydrogen forming the hydroxide ion. So we have one of each, one sodium, one oxygen, and one hydrogen. So I can come over here to my periodic table. I have sodium, which is element number 11, has a mass of 22.9897698. But as we've discussed, we don't need to use all of those. Usually 4 or 5 significant figures would be more than enough. So you could use 22.99 or 22.990 if you prefer. Either one would be sufficient. So we're going to take our 22.99 and add a single oxygen. Over here, this is 15.999. Again, if you wanted to make that into 16.00, that's fine. The only difference is you're using 4 significant figures rather than the 5 that are given on this particular periodic table. So I'm going to take the 22.99 plus 15.999 or 16.00 plus my hydrogen, which is 1.008. So just to make it simple, I can use 4 significant figures for all of these. So I have 22.99, 1.008, and 15.999 or 16.00. And I just add all of those up, which would then come over here and be our sodium hydroxide um, atomic mass unit for that. We're going to do the same thing with all of these compounds. The only difference with number 2 would be we're going to take that 1.008 and multiply it by 3. We're going to add that product to the mass of phosphorus. So then I go back to my periodic table. Here's phosphorus, 30.97. Add that to my 1.008 times 3. Head back here. Now I have 4 oxygen. So I'm going to take my 16.00 times 4 because I have 4 of them. Okay, and I'm just having you go through this. I know it's not overly complicated, but it's one of those things that if you don't know how to do it, it ends up being a challenge later on, and so that's going to throw off all of the rest of your calculations later on if you don't get the right molar mass. Okay, scrolling down here, this looks just like what we've done already. We've been looking at different problems just like this. So how many grams are in 4.5 moles of sodium fluoride, NaF? It's not really a big deal because previously what we've been looking at is just maybe how many grams are in 4.5 moles of sodium. Now we've just made it into an ionic compound. So in the red here, I have an answer for you, showing you all the work, so showing you my thought process of why I was doing what I was doing. So the molar mass of sodium fluoride is 22.99, that's the sodium, plus 18.998, that is the fluorine. Okay, and that gives me a total mass of 42.00. But Mike, you say, this number has 5 significant figures. This number has 4 significant figures. Why do we only have 4 significant figures down here? Think back to our significant figures rules. Keep in mind that when adding and subtracting numbers, you can only go to the last place that you are confident about. Okay, it's not the total number, it's the last place. So we have the tens place, the ones place, tenths, hundredths. So the hundredths place is the last place that we are confident about. We have tens, ones place, tenths, hundredths, thousandths place. And even though we have the thousandths place here, we're still limited by the hundredths place over here. So that means our answer can only go to the hundredths place. So I'm going to use the 42.00 grams per mole as my molar mass for sodium fluoride. So now when I set up, I take my information that I got from my problem, which is my 4.5 moles, put in my conversion factor, which is 42 grams per mole, or if we were to rewrite that, that would be 42 grams equals 1 mole, and so we could put 42 grams over 1 mole, or, depending on the problem, 1 mole over 42 grams. However, keep in mind, use your labels to make sure that you cancel out these particular labels. Okay, so moles are on top here. That means moles are going to have to be on bottom over here, so we can cancel those. We're going to take 4.5 times 42, divide that by 1, which ends up being 189 grams, which with significant figures rounds to 190 grams because I only have 2 significant figures here. So that's how we solve it. This is not new. It's just taking it one step further, so I fully expect that you can do that. I'll be posting this on Schoology so that you have access to the answer key at the bottom here. So check your work. Make sure that you're on the right track, and if you have questions, please let me know. I have another problem here that you can check, but since this is really repetition, the only thing that is new is figuring out these molar masses. I'll just go ahead and let you work. But again, if you have questions, please let me know. Shoot me an email, or you can talk to me after class or after school. Thank you.